Welcome back. It's been a while. Life's been busy, whatever. I'm going to change up the format of these a little bit. What I found was that I was finding it really hard to learn new concepts while recording and narrating live. So what I've got it to do is ask it to teach me concepts and handhold me a lot. I have a few messages above asking it to do that, and it started filling in my code again, and I told it not to do that. But it came up with this memory. I'll just read it, and this is, I think, how we're going to approach future lessons. Teach the very next single line of concept, ask him to write it, and wait. No file scaffolding. And no HTML plans for this project. So this is related to, I do other stuff on this computer, which AI writes plans, so I can read them and understand what they're doing. That's irrelevant here. So dumb it down, short chat messages, one idea each. That's one thing I hate about learning from AI at default settings is they cram everything that is relevant to the idea immediately in the chat window, and I just get overwhelmed. So one idea each. He explicitly values learning the concepts, not just the coding. Yep, that's what learning is. You're learning concepts and attaching them to your existing schemas in your mental model. So teach the idea first, stack versus heap, which is exactly what we do later on. In plain chat, and ask comprehension questions to confirm understanding before moving on. So quizzing, making me say the thing in my own words is going to be really helpful for learning. Do not show him the literal code or answer for the next step. Describe what's needed and the concept. Let him type it, make his own mistakes, then help him read the compiler errors. From my experience, this is how I learn best, and I hope that that's insightful for whoever's watching, for like the one person watching this. So I got it to teach me about the stack and heap, which we've covered in previous videos, but kind of understand it a bit more. I won't go through the entire thing. What I'll do is I will go over the code that we eventually write and try to teach whatever or not teach, but you know, let you know why I'm writing it the way I did based on what I learned. So yes, with the concepts that we covered, what is a dynamic array? How do we handle these three facts together? Well, we handle them in a struct. I ask it some questions about, do stack and heap live on different memory, like M1 versus M2? It turns out, no. It's just a logical difference in the same physical memory, which your program is allotted when you compile. I then ask it about O1 notation and what is this? Because AI loves to use this notation, and I've seen it around and I don't understand it. I didn't understand it, and so got it to quickly teach me about that and quiz me. And then we get into the code. So, from here on, we start writing the code, and I get it to just ask me, I get it to quiz me, and I get it to review. So I won't go over the rest of the lesson here, unless I get feedback to tell me to go through the lessons. But I am going to go over what we actually wrote and explain why. So we're including the two standard libraries, standard in-out, that's for printing, as well as printing to standard errors, and the standard library, which is going to provide, I don't even know what it provides. It provides everything. It provides exit and malloc. Well, there you go. Thank you, VS Code and extensions. So we define a struct, din array. Originally did it in a different way. I originally wrote struct din array and had the other stuff there. However, I then learned that if you do it that way, you have to basically type struct din array every time you use it. So using the type def, it's basically syntactic sugar, which then allows us to just refer to din array as itself, din array. And every time we refer to that, it knows that it's a struct. The struct itself does exist in memory, but it just contains 3 bits of data. So the data variable inside the struct is a pointer, and that points towards the first address of our actual data that the array is going to contain. The struct concept, the din array, struct also contains the information about the length and information about the capacity. So this struct is a nice compact little dictionary for our array. Then we have a function, new array, that returns a copy of the din array. And initially I had it returning a pointer because that's what we've been learning. However, because I have learned from VS Code, I have learned from the AI tutor that if you return a pointer from a function, that okay, I learned from the AI that when you declare something in a function and that function runs and then is returned, that local thing, that variable, no longer exists because internally the program wipes the frame that calls this function away. So we'd be returning a pointer to something that is then able to be overwritten by another function call. So we're returning a copy, an actual copy of the din array, which is fine because the struct is very compact, it's very small, and because we're returning the copy, when we eventually get it here, this array, this ARR variable actually contains a correct pointer to, this ARR actually contains a copy of the dynamic array, and that is then available for the rest of the program to run in main. So that's why this is returning a copy. So we are defining a variable ARR of type din array, which is a struct. Now we are asking for the memory to be allocated. And so this new array function takes in an initial capacity of our array. And so if we passed in 10, we would need 10 times 4, which is the size of an integer. We'd need 40 capacity. So we'd need to ask the memory to allocate 40 bytes. And we're doing it in this notation because sometimes the value is not 4. So if we write it like this, you're never going to get caught out by other OSs or weird cases where an integer is actually 8 bytes or something. So we're calculating the size of an integer and we're multiplying that by the initial capacity of the array. And so this data, because it's an malloc, that's either going to return a pointer to the start of the data or it's going to return null. If it returns null, it means that it failed to allocate the memory for this din array, in which case we are using fprint. That's like printf, except you tell it where to go, and we're telling it to output into the standard error that malloc failed to allocate memory. And then we're going to exit with an exit code 1. That exits the program right here instead of returning back to main. Anyway, if that is successful, then array.data contains a pointer to the start of the array, which has been allocated the size of the initial capacity. We then complete our dictionary definition of the din array with the length. We start with 0 and the capacity, which is the initial capacity that the function was asked for. And then it returns this ARR, which is a copy of the din array. So in main, we call this function and we are asking it for 10 capacity in the array. We are then printfing the pointer to the data inside the array because we want to know, to just verify that it's actually giving us an actual memory address. So you can see I've done it down here. It's giving us an address, and if I rerun it, is it going to give us a different address? It is. So it is at the point of running the program, the system is now looking into the memory and giving us a run of memory that is 40 bytes long, and it starts at this address. So that's step one. Next, we'll be moving on to growing the array and what happens when the array data reaches 10 spots and it fills up the capacity. We'll need to extend the capacity. That's next.